Imagine a man walking down the street completely invisible to the naked eye. He's there, but he's not. He's real, but he's unseen. He's not a ghost. He's not a figment of your imagination. No, this man is as tangible as you or me, yet he's completely concealed from sight. How is this possible, you ask? The answer lies in the magic of metamaterials. Let's weave a tale, shall we? Picture this. A man, let's call him John, strolls down a bustling city street. He's wearing something that seems out of a science fiction novel, an invisibility cloak, if you will. This cloak, made of intricately designed metamaterials, bends light around John, making him unseen to the world. He's there, but the light doesn't reveal him. It's as if he has become part of the backdrop, seamlessly blending into the cityscape. But what's more, is that this isn't just about light. The cloak also manipulates sound and electromagnetic waves, adding another layer of invisibility. The honks of cars, the chatter of pedestrians, they all seem to pass right through him. It's as if he's not just invisible, but inaudible too. Now you might be wondering, what are these metamaterials that make such an extraordinary feat possible? Well, metamaterials are not your typical matter. They are not found in nature. They are engineered, crafted to have properties that natural materials don't possess. They manipulate light, sound, and electromagnetic waves in ways that seem almost magical. John's cloak, for instance, uses these metamaterials to guide light around him, instead of reflecting or absorbing it. It's a bit like water flowing around a rock in a stream. The light simply moves around him, leaving no trace of his presence. Now this story may sound like science fiction, but it's closer to reality than you might think, thanks to the magic of metamaterials. So, what exactly are these metamaterials that can seemingly defy the laws of nature, you might wonder? Well, let's dive into it. Imagine a magic carpet from your favorite fairy tales. Just like the carpet can fly against the force of gravity and take you on extraordinary journeys, metamaterials are materials that can do things that seem almost magical. But instead of flying, metamaterials manipulate waves like light, sound, and electromagnetic waves in ways that natural materials can't. Metamaterials aren't natural substances that we find in the world around us. They're engineered. They're meticulously designed and created by humans to perform specific tasks. And what makes them so special is that they can have properties that no naturally occurring material possesses. Think of a piece of paper. When you crumple it, it changes shape, right? But it doesn't necessarily change its properties. It's still paper. Now, imagine if that piece of paper could change its properties based on how you crumple it. Maybe it becomes waterproof, or it could resist fire, or even becomes as hard as steel. That's what metamaterials can do. They can change their properties to interact with waves in unique ways. But how do they do that? It's all about structure. The magic of metamaterials lies in their structure, not their composition. It's not about what they're made of, but how they're made. The specific arrangement of their tiny components gives them their unique properties. These tiny components are smaller than the wavelength of the waves they interact with, allowing the metamaterial to control the wave in a very precise way. This is what enables them to do things like make an object invisible by bending light around it, or improve the efficiency of solar cells by trapping more light. In essence, metamaterials are like the wizards of the material world, bending and shaping waves in ways that no natural substance can. Their potential is vast, and we're just beginning to scratch the surface of what they can do. So the next time you think about magic, remember that it might not be as far-fetched as it seems. But how do these magical materials work? Well, to understand that, we need to delve a bit into the world of physics. Imagine a calm pond. When you throw a pebble into it, the impact creates ripples that spread out across the surface of the water. These ripples are comparable to the waves of light, sound, and electromagnetic radiation that permeate our universe. Metamaterials, with their specially engineered structures, work similarly to that pebble. They interact with these waves in a way that's unlike any naturally occurring materials. They distort, bend, and manipulate these waves, creating effects that can seem almost magical. But here's the catch. It's not the material itself that's special, it's the way the material is structured. Metamaterials are made up of tiny, repeating structures, each smaller than the wavelength of the light, sound, or electromagnetic wave they're meant to manipulate. This fine structure is what gives metamaterials their unique properties. Think about this. When you look into a mirror, what you see is the light that has bounced off the mirror's surface. That's how we normally interact with light. But when light encounters a metamaterial, something different happens. The metamaterial doesn't just reflect the light, it bends it, twists it, and sends it in directions that normal materials wouldn't. And it's not just about bending light. Metamaterials can also absorb energy more efficiently, making them ideal for applications like solar cells. They can manipulate sound waves to create super-efficient acoustic devices, and even control electromagnetic waves to develop advanced communication systems. The magic of metamaterials, then, lies not in their composition but in their structure. By designing and arranging tiny structures in specific ways, scientists can create materials with properties that seem to defy the laws of nature. So, just as a pebble can create ripples in a pond, metamaterials can create waves in the electromagnetic spectrum, altering how we perceive the world around us. You might be wondering, what can we do with these metamaterials? Well, the possibilities are as limitless as your imagination. Let's dive into some of the most fascinating applications of metamaterials. Invisibility cloaks, super lenses, and efficient solar cells. First up, invisibility cloaks. Sounds like something out of a sci-fi movie, doesn't it? But it's not. Metamaterials can manipulate light waves around an object, essentially rendering it invisible to the human eye. This concept, once a figment of our imaginations, is now a scientific reality. Invisibility cloaks could have extensive uses in the military, stealth technology, and even in everyday life. Next, we have super lenses. Traditional lenses suffer from a problem known as the diffraction limit, which restricts the smallest object they can resolve. However, metamaterials can surpass this limit. Super lenses made from metamaterials could allow us to see things smaller than ever before, down to the nanoscale. This could revolutionize fields like biology, where it could enable us to observe processes at the cellular or even molecular level in unprecedented detail. Lastly, let's talk about efficient solar cells. The metamaterial magic here lies in their ability to absorb and trap light. By engineering metamaterials with this property, we could design solar cells that can capture more sunlight and convert it into electricity more efficiently than current technology allows. Imagine a world where solar power is not just an alternative, but the primary source of energy, all thanks to the power of metamaterials. These are just a few examples of the incredible potential metamaterials hold. But remember, we're only scratching the surface here. As researchers continue to understand and manipulate these materials, who knows what other marvels we'll discover. From making objects invisible to improving our solar cells, the potential uses for metamaterials are as vast as the waves they manipulate. So where does the future of metamaterials lead us? That's the question we're left with after diving into the fascinating world of these engineered marvels. We've journeyed from understanding how metamaterials, with properties not found in nature, manipulate light, sound, and electromagnetic waves in novel ways, to exploring their diverse applications. In our quest, we've discovered that metamaterials are not just theoretical constructs or lab curiosities. They're already reshaping our world, from invisibility cloaks that could make science fiction a reality to super lenses that promise unprecedented clarity and efficient solar cells that could revolutionize renewable energy. But this is just the beginning. The future of metamaterials is as boundless as our imagination. They hold the potential to revolutionize various fields, much beyond what we've discussed today. Think of a world where buildings are designed with seismic metamaterials that can shield them from earthquakes, or where ultra-thin metamaterials could make bulky antennas a thing of the past. In the medical field, metamaterials could lead to breakthroughs in imaging, allowing us to see inside the human body like never before. They may even pave the way for treatments that target diseases at the cellular level. In aerospace, metamaterials could drastically reduce the weight of aircraft, making travel more efficient and sustainable. And let's not forget about their potential in computing. Metamaterials could enable the development of faster, smaller, and more energy-efficient devices, taking our digital world to the next level. However, as with any new technology, there are challenges to overcome. We need to refine manufacturing techniques, understand the long-term impacts, and ensure accessibility. But with continued research and investment, these hurdles are not insurmountable. The future of metamaterials is a journey into the unknown, filled with promise and potential. Each discovery, each application, brings us closer to a future where the ordinary becomes extraordinary, where science fiction becomes science fact. As we continue to explore and understand metamaterials, who knows what magical transformations they'll bring about next?